Okay, so this is the part 2 video to utility, and what we're going to do is see how we can turn this analysis, marginal utility over price equals marginal utility over price, into a demand curve. Ultimately, this whole assessment of utility maximization is to see what's behind a demand curve, digging in deeper. So, notice I blocked out a few numbers under water. The reason why I did that is because what we're going to do is we're going to change the numbers in water. Ultimately, what we're going to try to do is assess water so that we can create a demand curve for water. Now, in the previous video, you saw that marginal utility over price equals marginal utility price at 2 water and 4 gum. So what I want to do, the first thing I want to do is take that information and take a look at the demand curve for water. We saw that when water was $1, we bought 2 items. So what we want to do is draw a plot point at that location. When water was $1, we bought 2 bottles. Hence, we have a plot point. So we have 1, not enough to make a demand curve yet. So we go back to the numbers again. And what I'm going to do is I'm going to change something. I'm going to change the price of water from $1 to, let's say, in this case, we're going to make it 50 cents per bottle. Okay. So where did I get that number from? All I wanted to do was change the price of water. It was kind of a random choice. Drop it from $1 to 50 cents. When you do this on the test or on a practice exercise, if you need to create a demand curve for one of the products, assess mu over p equals mu over p at one price, then put your plot point, then come back to the numbers and change the price tag of the product that you need to create a demand curve for, and then reassess. So, using ceteris paribus, gum is unchanged. We're not messing with gum. We're going to hold that constant. The budget is unchanged. We're going to hold that constant. The only thing we're going to change is the price of water. Now notice the total utility column is the same as it was before. We're not messing with our levels of satisfaction, we're messing with the price tag. Well, since our total utility is the same as it was before, the marginal utility also remains the same as it was before. What changed is this price tag right here. So what I need to do is reassess this equation. 15 marginal utility, see if I can do this way, over 0.5 marginal utility, boom, which has not changed, over the price tag, which we have changed. So that's going to yield a new set of numbers. Pause the video for a moment and go ahead and calculate the mu over price of water using the new price tag. Okay, so moving on, we see that 15 over 0.5 is 30. 12 over 0.5, 50 cents, is 24. 9 over 50 cents, 18, and so on. So we now have a new set of numbers. Erase that for a moment. All right, good. Let's erase this too. All right, good. So again, we assess it like we did before. We want mu over p to equal mu over p. Take a look down here. We need to find this. So we have 2 locations in which that is true. Water, 30, no 30 at gum. 24, no 24 at gum. 18, no 18 at gum. 12, we do have 12 with gum. That would be 4 water, 4 gum. We also see, 10 doesn't match up with gum. 8 does, so we see our second location here, 6 water, 5 gum. Now we need to make sure that we have a combination that fits in our $4 budget. 4 water at 50 cents is $2. 4 gum at 50 cents is $2. 2 plus 2 is 4. That fits. 6 water and 5 gum, I can't afford it. That's more than $4. So that's not a combination we want to use. So we go down here, erase this, and what we see, mu over P equals mu over P at 4 water and 4 gum. So we have a new utility maximization level. So go back to the graph, and we now see that when water is 50 cents, we buy 4. 50 cents. Put it, the plot point, line it up good. Okay, put the plot point. We now have 2 dots. 2 dots is in fact enough. Good, I have that. 2 dots is enough to connect the dots. I want to extend the line on down to make it a full-blown demand curve. I don't need to touch the axis, that's sufficient. Of course, I need to mind my P's and Q's, so I'm going to call that a demand curve. And make it a little bit bigger. Excellent. We now have a demand curve for water. Now, obviously, in reality, we assess and we buy more than 2 products. Remember, this is a simplified model to help us understand the basics, and we use ceteris paribus. However, that's what's behind a demand curve, is this utility assessment. As an afterthought, what happens if, let's say my budget, let me erase some of this stuff. Get rid of that. What happens if my budget is different or is higher than the combination? What I mean by that is, let's say my budget, I'm going to change my budget. Let's say my budget is $4.50. This is horrible. Okay, so change the budget to $4.50. I'm going to leave water at the 50-cent price. So water is going to remain 50 cents like we just did a moment ago, and gum is still 50 cents. So we know that for water and for gum, that's what we're going to purchase. However, by doing that, I've only spent $4. I got an extra 50 cents sitting here. It doesn't come out nice and neat. Well, what do? Do I buy 1 more water, or do I buy 1 more gum? Well, the question is, which one of those, the 5th water or the 5th gum, will yield a higher total utility? Well, if I get the 5th water, I'm going to gain an extra 5 utils. That's the marginal utility going from 4 to 5. If I buy an extra gum, I'm sorry, not 6, I meant 5. If I buy an extra gum, which would be 5, I gain an additional 4 utils. Obviously, if I buy an extra water with that extra 50 cents from my budget, I get more levels of satisfaction from that choice than I would if I bought gum. So given this situation, I would in fact buy 5 water, 4 gum. So that's what happens if the budget doesn't come out nice and neat. But keep in mind, you want to try to spend your entire budget in one way, shape, or form. Keep in mind that we're trying to maximize total utility, which means whatever combination I choose, add the total utility of that choice of one product to the total utility of the choice of the second product, and I want that number to be the highest possible. There you go. Please come to class with any questions that you may have. Very good.